Alright, Mr. Palmer here, 1:15. I'm going to knock this one out super fast and then hit the sack. Okay, so before you do this, make sure you go over your notes on Quicksort and you're going over your notes on recursion. Alright, so while you're going over your notes, bit of salt and pepper bean curd right there, and here we go. So Quicksort, this is the algorithm for it. So remember, I showed you two different ways of doing a Quicksort, and I said that I prefer the in-place Quicksort because of the memory requirements being reduced. Okay, so remember, Quicksort is the recursive divide and conquer approach, which is making use of multi-branching. All right, we are moving the left pointer until the right item is smaller than the left, at which point we swap the items and we start comparing from the right this time, moving towards the left of the partition, and we keep doing that until the left and the right pointers meet, at which point we've identified a pivot. So then we can repeat the recursive call for the left partition and for the partition on the right. So here's my start of my recursive function. Remember, I'm going to keep doing this while left is smaller than, so while left is not equal to right, okay? Because at the point where the left and the right pointers hit each other, that's when I know that I've identified my pivot, okay? So while list left is smaller than list right, I'm going to keep incrementing the left pointer, so I'm moving towards the right hand side of my partition. Okay, so you can see here in the first version of my partition, I was comparing Bob to Taj is smaller, Joe to Taj is smaller, Anne to Taj is smaller, Tom to Taj is larger. Okay, at this point I exit my while loop. When I've done that, I now need to swap the list left and list right. So the two items are now in the correct order in terms of being ascending. Okay, if you're I was about to swear there, but you're struggling with the code on how to swap two items, remember temp is going to be equal to the first item, the first can now be equal to the second, and then the second can be set to the temp. So all the values are basically moved in a circle. All right, now I can do the same thing for the right hand side of my array. So I start to move my right items. Okay, here my right pointer, here I move my right pointer for the first time. This was the left hand item is larger than the right hand item, and so therefore they need to swap around. Okay, and there we go. Okay, and then because I'm in my while loop, I can now go back around and I start moving my left pointer again. Okay, once I keep doing that, once this top condition of my while loop is no longer satisfied, you can see in this case left is now equal to right, because my left and right pointers have are now equal to each other. I've basically identified my first pivot. Okay, so now I can basically call a Quicksort on the left partition. So in the beginning, when I called this function, if I passed 0 as the minimum and the maximum being 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all right, I'd be able to now do a recursive call for Quicksort min, which is 0, and left minus 1, which is 1, 2, 3, 4, 5, 6, 7, 8 up to Leah. Okay, because Leah is at 8, so the pivot being 9, and then Quicksort left plus 1, which is going to be 10 to 11. Okay, so you can see how my recursive call will now then go back into 0, 8 and do the same thing, shifting the pivots for the left partition, and then the 10, 11 call for the right hand partition, and performing the same function. Okay, so you should basically be able to look at this now and use this to help you implement an in-place Quicksort. That was quick and easy. Good night. Here we go.